Okay, welcome to the first psychology video on the channel, and this is for AQA Psychology, Biopsych, and we're looking at synaptic transmission. So just to be clear, if you do A-Level Biology, you might need to go into much more depth than this. This is what you need for a basic description of synaptic transmission for AQA Psychology. We have Pedro here from the physics videos to help us through this as well. And here we go. Let's do this. So first of all, what we've got here is a zoomed in picture of a synapse, so the connection between two neurons, and we're going to have the connection going this way. So there is an electrical impulse traveling down this neuron, Now, we don't need to go into a huge amount of depth on how that's working on a specific level, but I would like you to use the term action potential. Action potential, think potential difference from your GCSE physics when you were doing electricity. And action potential is this electrical impulse that travels down the axon of the neuron. Okay, and it's going to get to the end of the neuron. So the end of something we often call the terminal station. Okay, what's it the terminal to? Well, here's the synapse. We're going to call this gap the synaptic. Synaptic cleft. That's the gap, or the synaptic gap is fine. So if this is the synaptic cleft, this is the terminal before we get to the synapse. So it's also before, so it's the presynaptic terminal. Pre because it's before we get to the end of this neuron and before we get to the synapse. So that's the presynaptic terminal. At the other end, we have the post. So the postsynaptic. In this case, we're going to say membrane. And if you had membrane in the first bit, that would be okay, but we're going to go with presynaptic terminal. Okay, so an action potential sends along the axon and gets to the presynaptic terminal, where there are these little packages of chemicals. So the packages themselves are called the vesicles, and inside we have neurotransmitter. And in psychology, often we're talking about dopamine or serotonin. Now, depending on this message that comes down from the action potential, that might cause the vesicles to release neurotransmitter into the synaptic cleft. Okay, and on the other side, in the postsynaptic membrane, there are active sites or receptors. Okay, let's stick with receptors. There are receptors that pick up or can pick up these neurotransmitters that are released into the gap. Okay. Now, these receptors will pick up the neurotransmitter, and depending on the neurotransmitter, that will send a particular signal. It might be an excitatory signal, or it might be an inhibitory signal. Okay, so it's either exciting the neuron and getting it to fire, or it's inhibiting the neuron and reducing the likelihood to fire. Now, bear in mind, we're just looking at one synapse here. Each neuron might have thousands of connections. So it's going to sum up all those connections, all the information, excitatory and inhibitory, and we get summation, the summing up, adding together. So this particular synapse might be excitatory, it might be inhibitory, but remember this neuron that's picking up this information has got thousands potentially of other synapses, and it's collecting all that information. So if the message from this one is excitatory, then this is more likely to fire, and an action potential will be created and sent down that neuron to another one. If it's inhibitory, then that makes it less likely to fire. Okay, so there is a basic description for AQA A-Level Psychology of how to describe synaptic transmission. An action potential passes along the axon of a neuron. It reaches the presynaptic terminal. This can tell vesicles to release neurotransmitter into the synaptic cleft. These are picked up by receptor sites on the postsynaptic membrane, and that information can be either excitatory or inhibitory, and the summation, the adding together of all the information from different synapses makes it more likely for an action potential to fire if the messages overall are excitatory and less likely if they're inhibitory. I hope that was useful. If it was, and I can make more. Put any requests in the comments of anything you want for AQA psychology. But until then, thank you for joining me.